All right, well, now we're going to look at maximum and minimum values, how we can determine those algebraically for a quadratic function. And just before we get into that, let's take a look and we'll review some of our key concept information regarding the graph of a quadratic function. And so first, if I look right here, it says consider the graph of y equals ax squared plus bx plus c, where a is not equal to 0. Now this is going to give us, this is what we call the quadratic function in standard form. And it tells us, and from that equation itself, there's a lot of things that we can determine. Well, the first, we'll just go down in order. First is the y-intercept. Well, this y-intercept is always going to be equal to c. Because if you remember, if I want to find the y-intercept, I set x equal to 0 and solve the equation, and that's going to give me that y-intercept. Well, in this case, if I plug in 0 here at x squared and 0 in here at x, you can see, well, a times e 0 squared, that's just going to be 0, and b times 0 is going to be 0. And so what I'm left with is this value of this constant, or c. Now, we can find the axis of the symmetry of x, as well as what is the x coordinate at the vertex, by using this little formula, negative b over 2a. Now, let's go back up here and let's define what is b and a. Let's start with a. Well, a is the coefficient of the variable squared in a quadratic function, and b is the coefficient of just bx. So we're talking about the coefficients in front of the variables, and this is going to give us negative b over 2x. Gives us both the axis of symmetry in a quadratic function, as well as the vertex, or the x value of either, and this is leading us to the maximum or minimum values. Now, if a is greater than 0, and it cannot equal 0 for it to be a quadratic function. If a is equal to 0, then my graph, that U shape, is going to be arms up. And so at the very bottom of that parabola, that's going to give me a minimum value of y. So in other words, at that x coordinate, whatever that y value is, that's going to be the minimum value for y, or it helps me to find the range, you could say. Now, if that a value, that coefficient of x squared, is a negative number, well, this is going to be an arms down. It's going to be an upside down parabola like this, and that's at the vertex, that y coordinate at that point of where for that x value is going to give me a maximum value. So when we're looking at finding minimum value and maximum value, if I'm doing that from an equation, first thing I want to do is find where that vertex is, and then plug in that x coordinate. Because when I'm finding the vertex, I'm finding an x coordinate. I plug in that x coordinate into my quadratic equation and solve for that, and that's going to tell me what that y value is at the vertex. Now, I can recognize instantly whether it's going to be an maximum or minimum value also by that coefficient in front of the x squared. If it's positive, the arms of that quadratic parabola is going to be up, and therefore I'm looking at a minimum value. And if it's negative, I've got an arms down in behavior, upside down parabola, and at that vertex, that y value is going to be my maximum value. It's helping me define the range, if you will. So let's take a look at one real quick, and we'll figure it out how to do it. Okay, so now we're being asked to consider here when f of x is equal to 4x squared minus 24x plus 11. we're asked first to determine whether the function has a maximum or minimum value. Now, I can solve that pretty easily by looking at this lead coefficient right there, 4x. Well, 4 is greater than 0. It is positive. And given that that lead coefficient, ax squared plus bx plus c, given that that is a positive number, I know that that f of x is going to have a minimum value for this quadratic function. Now it says to state the maximum or minimum value. Now in order to first do that, I'm going to use this little formula to find the vertex. I want to find what that x-coordinate is first, and then I can use it to find the y value, which in this case is going to be a minimum value. So I got negative b over 2a. So let's substitute what we know here. I got a negative, and b is negative 24 over 4, times 2. Let's say I wrote that wrong. Let me just, I don't want to confuse anybody. 2 times 4. Well, let's see, what does that solve to? I still got a negative sitting out here. I got negative 24 over 8. And when I take negative 24 divided by 8, that gives me negative 3. But I got a negative. So here I got, let's just write it like this, negative 3, which of course my vertex is going to be 3. Now, in order to determine what my y value is there, I'm just going to plug this 3 in to this equation. So now I've got 4 times 4x, 3x squared, minus 24 times 3 plus 11. Well, let's see, 3 squared is 9, so now I got 4 times 9. And let's see, negative 24 times 3 times 4 is 12, carry 1, so that's negative 72 plus 11. And so that's going to give me 36 minus 72 plus 11. And when I solve all that, I'm going to end up with 36 minus 72 is going to give me negative 36 plus 11. My minimum is going to be negative 25. In other words, when x is 3, y is going to be negative 25. Now, the third part of this is we're asked to state the domain and the range. Well, my domain is going to be equal to all real numbers. But this minimum value for the y is defining what my range is going to be. So my range then is where f of x, or y could say, such that f of x is greater than or equal to negative 25. And so there we go. We've determined it had a minimum value. We calculated the minimum value by first solving for the vertex, then plugging that x value into our original quadratic equation, solving that. That gives me the minimum value. That gives me the y coordinate at the vertex. And then that y value defines the range for me in this quadratic equation. We're going to take one little quick look at the calculator and prove what we just said. Okay, so here we are at the calculator, and let's plug in our quadratic equation. We have 4x squared minus 24x plus 11. Now, I'm going to bet right now that I won't be able to see that minimum value, but let's go ahead and just graph the thing anyway. What do we got here? Okay, well, I can see I got something of a parabola, but my window setting set at x minimum of negative 10, x max at 10, my y value minimum is at negative 10, and my maximum is at 10, and I'd kind of like to see the bottom of that parabola, so I'm going to have to make a window adjustment. But what do I think I want to do? When I've already calculated algebraically that my minimum value is going to be negative 25 for y, so I want to at least get that maybe down. Let's put that at negative 26 so that it's going to at least go beyond negative 25. And I think when I do that, I think that's the only window adjustment I'd really have to make to see the very bottom or the minimum value of this parabola. Let's see if that's going to work. Okay, there we go. And I can see that this minimum value is sitting here. It's corresponding when x is 3. And remember now, I set the minimum at negative 26. And so there's my point right there. When x is 3, y is equal to negative 25. And we can see that that is defining my range. In other words, f of x, the range is f of x such that, and when you see one little straight line in function notation, then that is defining that minimum value. In other words, y is never going to be less than negative 25, or I could say that y is always going to be greater than, it's got to be greater than or equal to, excuse me, negative 25. All right, so there we go. That's a little quick tutoring on minimum and maximum values of a quadratic equation.